The triangle area formula is based on the area of a parallelogram. So we found before that if you have a parallelogram, that the perpendicular distance between the two bases is called the height, and the area is based on multiplying the length of one base times the height. Well, we know that there are two triangles for every parallelogram. We can take any parallelogram and split it into two congruent triangles. So here's an example. So therefore, the area formula for a triangle is 1/2 the area of the base times the height, or 1/2 the length of the base times the height. In order to identify the base and height in a triangle, draw a line from a vertex so that it's perpendicular with the distance of the triangle across from that vertex. Imagine that the triangle is half of a parallelogram. To see the height, or imagine the height is connecting the vertex to the opposite side, even if you have to extend the opposite side. So if you can imagine in this particular diagram having a parallelogram, it would come something like that. Here's our parallelogram, and our height would be the perpendicular distance between the two bases. So up here at the top we'd have a base. Here at the bottom we'd have a base. So it looks something like that. Okay? So we'd look at that length down here of this base, and then we'd look at this height, and that would be the base times the height for our parallelogram. Our triangle is half of that, so we're going to be looking at the length of that base times the length of that height, and multiplying that times 0.5 on our calculator. But when we draw the triangle, we don't have the entire parallelogram, so often the way that we'll draw the height is it's going to be the perpendicular distance from one side, where one side is the base, up to the opposite vertex, and that's how you'll recognize it. Here's another example. So here we have an isosceles triangle, or an acute triangle, and if I go from a vertex to the opposite side so that it's perpendicular, then my height goes right through the middle, and then I have my base as the side. So I can have more than one pair of bases and heights. We can have 3 pairs of heights and bases with any triangle because we have 3 vertexes and 3 sides. So here I showed you one height with its base on the other side. Now if I go from another vertex to the opposite side, I can see another height and base. These are all different measurements. And the same thing with the third vertex. So we can have 3 pairs of bases and heights with any triangle. Now with an obtuse triangle, they're harder to see, and with a right triangle, 2 of them will be the same. What you need to keep in mind is that bases and heights are always perpendicular. That's how you recognize them. Bases and heights are always perpendicular when they go together. So our first triangle here is an obtuse triangle. With an obtuse triangle, this is where sometimes it's helpful to draw the heights outside of the triangle. So here I have an obvious one that comes from the obtuse angle across. That's an obvious height to go with that base. Then I can extend this side here and bring the height straight down. That height goes with this base. Now, the base is the length of the side. It does not include that extended dotted line. It's just the length of the side itself. It just helps you to identify the height that goes with that side. Okay? And then, so for the third side of our obtuse triangle, we're going to look at this green side here. That's going to be our base. And then the height has to go from this point right here, this vertex, and it has to be perpendicular to that green side. acute triangles are pretty easy to see all the pairs of the bases and heights because they just go right through the triangle. With a right triangle with the bases and heights, we have a really obvious one here. So there's a height that goes with this side that is a base. They're perpendicular to each other. And then we have two sides that form a right angle. So this can be the height to that base. Or that where I just put a base, that could be the height. And then the red side could be the base. So you do have three pairs of bases and heights, but it looks like you only have two when you have a right triangle. All right, so once again, we can look at, here's a rectangle, which is the same thing as a type of parallelogram. And you can see in this picture that area is how many squares you have inside of a figure. So half of our parallelogram is our area. So the area is 1/2 base times height. So you can see in this particular picture, the length is 4 centimeters, the width is 3 centimeters. And we know that base is the same thing as length with a rectangle. Height is the same thing as width with a rectangle since they're perpendicular to each other. So we're going to put 4 in the place of B in our formula, 1/2 base times height. We're going to put 3 in the place of H, and we get 6 centimeters squared because it's half of 12. In this first example, our width is 3, which means this height right here is going to be 3 centimeters, and the length is 4, which means that base down there is 4 centimeters, and they're perpendicular. So 1/2 3 times 4 is 6 centimeters. 96 and 58 are perpendicular to each other, so you multiply them and divide by 2, and you get 2,784 units squared. In our obtuse triangle, 8 and 6 are perpendicular to each other, so they are the base and height. Since 8 and 6 are perpendicular to each other, they are the base and height. So 8 times 6 is 48, half of that is 24, therefore the area of the triangle is 24 units